Welcome to our third and final webinar of our short webinar series in Automation Studio 7.1. Thank you all for joining us today. My name is Bruno Dupuis, Technical Sales Representative for Automation Studio here at FAMIC Technologies. I'm joined here by my colleague Vincent Rémiard, who will be presenting today's content. So our first two webinars covered the vast majority of new features and developments in 7.1. The first having covered the development specific to training and technical publication content, and the second covering everything else really everything else related to the new features developed in Automation Studio 7.1, including web catalogs, the naming rules enhancements, the new component models by technology, as well as the new Mitsubishi PLC. The third webinar today will cover the 10 best practices of Automation Studio to follow when working with the software. This webinar is really based on some frequent mistakes encountered and aims to propose a structured process when working with the software and how to correct those mistakes. So this will cover some of these agenda. Again, my colleague Vincent will be going through each of these topics individually to showcase some of the best practices related to each of these topics. And we go really by a structure of the project creation phase all the way to the project publication and delivery. So for the GoToWebinar instructions, so during the presentation, you can ask your questions anytime using the chat that's available. Our colleagues will be able to answer your questions during the course of the webinar, and if there's any questions that we find relevant, we want to be able to share with the rest of the users, we'll be able to take that and use it in the questions session at the end of the webinar. So if anybody's having any audio issues, of course you can't hear me, but this slide is for you. So although you can't hear us, we hope that the note of this slide can help you at least to set up your telephone or computer audios in order to be able to adjust some of your sound settings. So this, you can go directly to your sound settings. You can choose the right sound setting to be sure that you can hear us during the presentation. So finally, I'd like to inform you that this webinar will be recorded. A link will be shared with all registered participants so that you can review the content presented as needed. And without further ado, I'd like to pass the screen over to my colleague Vincent so that we may begin today's presentations.
Thank you, Bruno, for the presentation. Let me start sharing my screen. So we're going to explore the 10 best practices as explained by Bruno, so that will make you more efficient using Automation Studio. It's a good refresher for people already knowing Automation Studio with this 7.1 release. So first thing first, before doing anything with Automation Studio, we propose that you set up a couple of things in your Automation Studio interface. So I have Automation Studio open here, and what you see, it's standard default template when you first install Automation Studio. So a blank sheet of paper, library open, and so on. So of course I can start creating my project from there. But we do suggest to have already to take some time to create your own template. So this will also make sure that a lot of layout of the components, colors, and so on will already be available as you draw your project. So if you create a new project, let me start with one. You see, there's a bunch of already existing template that I have here. I have one that we use for demonstration here, which is called FAMIC Technologies. So this project contains, as you will see, as I'm opening a new project or creating a new project from here. So this project contains two types of diagram, one fluid, one electrical. Okay, so for those that deals with multi-technological system. So today we're going to focus on the hydraulic mainly. So this template, as you see, I have already some logos here, some map locators, some of those aspects that can be standardized, and the way that you use Automation Studio will be available directly from that template. There's a lot of those aspects also that we're going to explore through this webinar. Okay, so starting from a template, of course, taking some time to create the template, we can give you at the end of this webinar more information on where to start, how to create the first template, and so on. But at this stage of the presentation is just to remember you that you can start from an existing template and so on. Other aspect also before as you set up the Automation Studio interface, if I click on my Automation Studio logo here, I have an Automation Studio options. So a couple of options interesting that you could explore regarding some manipulation of your mouse buttons. Some that you can change for some specific workshop that we have in Automation Studio dealing with 3D, for example, and so on. What is important at this point is the locations where those templates are located, where you can find this shared catalogs if you work in a group of users of Automation Studio. So basically, the default path, it will be a local path in the program data of the users that I am here. But you can browse and select a shared drive for those template or enterprise standards and so on. Okay, so for this first point, let's really stop there. Remember you once again. There's a template that you can use, and make sure that you have defined your location for those templates. So like that, every time you save a template or you move a template, you share that to a colleagues. Make sure that this path point where the templates are. Okay, so let's move to the second aspect, really important also in the good utilization of Automation Studio, is really, there's a lot of manipulations in Automation Studio when you move the components and so on. We'll focus really on the basic one and give you some tips that you learn from a training, but sometimes you forget about that. So we'll take some 5-10 minutes to explore those basic manipulation once again with you. Okay, so let's start from this empty project. You have your library here. So of course you can select the components from this library. So let me build a project from scratch. I'm using the control key just to show you that you can select a lot of components at once from the library, okay, by using the control key. And when you bring those components in, they will all be positioned like that. So you have your component from here. I have bring them in my schematic. I could have done this before, but before I really make the connection and I move them, will be important really in the view tab that you activate the grid. So this is the first thing that we suggest as you start creating a schematic of components. I don't know if it's clear on your screen, but you see there's a little, if I zoom in, there's some grids here. This grid has been automatically defined to make sure that all the connection points from the components available from the library or the catalog will be but this connection point will be on the grid. Okay, so as I move the component to make my schematic a bit more how I want it to look, you'll see every time I move the component, okay, using my mouse or using the arrow of my keyboard, the component will move from one grid unit at the time. Okay, so I just make sure that I position the component approximately where I want them to. Okay, I want them to be, and okay, so there is a couple of manipulation that you may have seen me doing as I was presenting. So we'll just recap some of those. So the zoom, if you want to zoom where the components are to have a proper view, of course, you can always use the right click here. You can use also in the view tab, there's all those zoom information available. So there's 2-3 locations or ways to activate those functions. But if you use the keyboard and the mouse, you will begin to be much more efficient. So for example, if I using the roller of the mouse with the control key, I will be able to zoom in. Okay, if I press the space bar, I will be able to pan my components and really to center them in the front of the paper space that I have. Okay, so basically, when you work with Automation Studio, of course, you have one hand on your mouse, and your fingers should be around Control, Shift, and Spacebar key. Those are the keys that are the most used in Automation Studio. Okay, so if I show you utilization of the Control key, for example, you will be able to duplicate the components. So using the Control key, duplicate the component, control key with the roller, I zoom in, zoom out where my mouse is pointing. Okay, so this is for the control key utilization. The connection of the component, of course, you click on one component, you make that connection. Let me work on a blank sheet of paper. So you complete the the connection where you can. Okay? So there's other shortcuts of the keyboard that can be defined. Let's say you want to flip this component. Of course, right click, you are able to do some transformation, rotate, or flip. You can use the Control R as listed here. You can define your own shortcuts. Okay, so me, I like this shortcut. So Control R using this component will flip it. Okay, I get here, I make the connection, forget double click, will automatically break the lines and so on, and you complete your schematic. Okay, like that. Okay, so let's say that oh, you forget you wanted to add another or an extra component inside this line. Okay, so I can go here. I think I do have a filter from here. No, I will go here and search for my fluid conditioning. Here we go. Okay. I have my filter here. Just remember that if you want to put a filter at the return line, as soon as you drag and drop from the library, you bring this filter into the line like that, automatically the filter will be inserted into the lines. Okay, so fine if you want to do that from the library. Let's say that you position it first. If you want to do the same, it will not work until you are using the control key that will make a duplication plus an insertion, or if you use the shift key, this will allow you to insert the component in. Okay, so this utilization of the shift key will allow you really to bring a component and break the lines and insert that component. The same if you want to remove it, okay, you use back the shift key once again. Okay, so this makes the filter removed from the lines and the lines is connected. If you do that with a pump, well, this may not happen. You will not. The line will not be rebuilt because the lines were built after the pumps were inserted. Okay, but it's easily you can bring another pumps if you wish the same way. So you don't need to erase the component. You can only or you only need to bring it in. And of course, in this case, this line will be break into two lines with equal equal length and so on. Okay. So this is about the manipulation. So utilization of the shift key to insert component. With the shift key, we'll be able also to perform a multi-selection over a bunch of components. Okay, and let's say you have some components that are close together. Sometimes it's difficult to select the right one, so the shift key will toggle between the component that may be a bit overlapped. Okay, so this is about the basic manipulation using the shift and control key. Another utilization of the control key will be to follow hyperlink that you can have hyperlink that you can have as you create some textual information and so on. So the control click will prompt you to the hyperlink. Okay. So there's a couple of things that you should avoid as you work with Automation Studio to change the layout of some components. For example, you go here, you do have access in the Edit tab to change the line style using this. We do not suggest to do that for the hydraulic component. The hydraulic component, all their colors, shapes, layout will be managed by the standards. So those color modification here are good for CAD object that you insert to enhance your project. But for all the components, we do suggest to use the colors coming from the template. For lines, we do have specific function for lines. So if you right click here, after you have defined line functions in your template, you will be able to use them. Okay, so I will use it a return line. So by default, as you select these return line here, you can use another return line to see the difference between those two. Return two lines. Okay? The color will change, and the shape of those lines will be really according to the defined standards. Okay, so select the lines. It's really a good thing that you should do all the time. Okay. Other things that you should avoid to do is to really rescale the components or the circuit if you want to increase the size of the component. Okay. let's say that you group them and you want you unlock the size from here, and you want them to put a bit more, or to be a bit bigger in the small paper space that you have. So what I've done, I have rescaled all the components. This will be really dangerous. Okay, this may bring some of the lines to fall outside of the grid. Okay, so the rescaling of the whole circuit, as I just done, or the individual component, it's something that we try to avoid. If you want to reduce the size or to increase the size of the drawing space, best thing to do is really to go here in the Home tab, and you could select predefined size. So let's say that I take an NCA. Okay? So you see paper space will be much smaller, and you will make your schematic fit perfectly where you want it to. Okay, so this works. The same, similarly to that, let's say that you have a big circuit or small circuit, and or you have a lot of components and you don't have enough space. Instead of rescaling the components or the circuit, we have a small scaling factor here. So what it does, it will make the components be bigger for a same paper size. Okay, so if I reduce the scale, so you see I do have the same technical paper size here, but my component and my grid will be all scaled together. So like that, all the components will be falling on to the grid. Okay, so we'll just get back to where I was at. Okay? So this is where you see you should avoid rescaling. It's the same for the components. By default, the size is locked. If you really want to resize it, you can do it, but make sure that you make a proportional transformation if you don't want your cylinder to look messy like that, to avoid also having the connection point falling outside of the grid. Okay, and if you really want to reuse a manual rescaling, if you right click here in the transform, not in the coordinate and orientation, or from the edit tab, you have the exact size of the boundary box of the component. So you could multiply or divide the width and the height by a multiple or 2 or 4. This will increase the chance of having the connection port falling to the right spot. Okay. So that's it about the things that we want to avoid. There is another type of mistakes or manipulation that you should be take care of. Okay, so I will show you. For example, you have this line here. You feel that this relief valve is a little bit it's too close from the pump, so you want to move it up. So easily I bring it up, and after that I bring my lines up. Okay. Perfectly. This is what I wanted to do. Maybe I want it to be in line with this one here. So seems perfect, but okay, for the for people using the software, you know, or aware about ISO standards, you know that this represents the connection port. So this connection port hasn't been carried with the manipulation of my components. Okay. So this will bring me to another and a really interesting feature, really to diagnose those type of mistakes, really to ensure before you want to analyze, or before you move to the simulation aspect of the software, make sure that the schematic is really nicely drawn, that you don't have much mistake in it. So the tool that I will explain here or explore with you is called the diagnostic tools, fall under fluid tab. It's really diagnosed on the schematic. Okay? So there is a couple of things that I can check here. The free connectors, the redundant links, the links that are superposed together, some components that may be invisible. Mechanical connectors, there's other ones that you could explore. Those are the ones by default that I like to activate, just to have a first diagnostic of my circuit. So as soon as you click on that, you will see a message. The message explorer will open and will tells you for each diagnostic. So no free connectors. I'm fine with that. Oh, there is some superimposed link here, and you have hyperlink. So if I click, you will know with this really highlighted mode where the mistakes is. Okay, so for sure I do have disconnection ports. So one of the reflex of the people is to just go there and erase the lines. We also suggest not erasing any lines, especially at the when your project is almost done, because you may have give some identification, some information, some sizing to those lines. It's always better to move the lines from the grips here, to resize the line or to change its layout. So like that, the lines will only change its layout, will not change any internal properties that you have given. So just from here, if I redo this diagnostic again, okay, just make sure that the second one has been done 1 minute after. I have nothing found from my diagnostic tool, so I'm good to go. Okay, so it was a big part of my presentation, this basic manipulation. I hope those were a good refresher for some of you. Now it will be time to move to the third point, which this one is a really important aspect of the utilization of an efficient utilization of Automation Studio, but I will not spend a lot of time with it because it's so important for most of our users that we have dedicated webinar to it. In every webinar that we have, we spend a lot of time to re-explain that. So let me just give you a couple of complementary information with the catalog utilization. Okay, so first of all, you have your catalog here. You have download them from the website. The web access will be open really briefly. They are ready to use, so you open them and you navigate with them. Okay, so if I take this one, which is open on my screen, something that maybe you people still not aware is we don't have only one pumps for the P1 PD in that case. There is here a configurator for those components. Okay, so when we do create manufacturer catalogs, we make sure that we make available all the publicly available options for those catalogs. Okay, so you just go here and the part number, all the information, simulation information will be selected as you navigate with it. Okay, so it's a little thing that we wanted to clarify. So part number here will be updated based on your selection, and of course, if you change, if the options change the symbol will change. And also, in the document tab that you have here, as you may know already, we do propose a test bench for each of the components we have in our catalogs, and the test bench will change as you change. Let me try to have like a load sense control instead of what we see. Symbol have changed, and there is another PRX here. Instead of being C1, it's a C0, it's a L0, which will make sure that the test will test this configuration of that specific component. Okay, so that's it about the catalog. We'll never say it enough. The utilization of that catalog will make you save time. Even if you are not finding exactly the right components, everything that we have in the catalog is configurable. Of course, you will maybe not configure something that the manufacturer can produce and so on. But if you are interested for the symbol specific configuration or to use these catalog symbols as a basic information to create another components, you can go there. You just need to really to deassemble it, or to exit the assembly. We'll get back to that later on. Okay, so that's it about the catalog utilization. We will guide you to some videos specifically or some webinars specifically for that aspect for those who still want to get more information. Okay, so this brings me to the fourth part of this presentation. We do and we still have people want to build a proof of concept out of Automation Studio, don't know which manufacturer you're going to use that you're going to use for your project and so on. So this main library contains all ISO standardized symbols. We have built all our manufacturer catalog with those basic behavior and so on. But when you use this library, there's two, three little things that we suggest you to take care of as you use those components, especially if you want to simulate later on. Okay. So the first thing is this cylinder that I selected from this main library is a defaultly, I would say, configured cylinder. Okay? So all the information of that cylinder contains default properties. Okay, of course. Well, at the early stage of your analysis, or even if you want to simulate to see the color as function of the pressure, you will need to set some loads. So really important in Automation Studio to always bring a certain level of load in your system. Okay, circuit that will work at zero load will be difficult to make it realistic as you launch the simulation. Okay, so for this cylinder, there is a couple of ways, different ways to add load. You can add an external load here, a constant, or resistive force that will react to the motion of the cylinder. The external load will always be acting. Okay, make sure that you also set the inclination. Okay, as really illustrated with that little picture here. Okay, so you can set load using constant value. We have also curves that can be set. Those curves are function of the position. So really an easy way to simulate a mechanism, making the cylinder load the function of the trigonometrical position of the system and so on. So you can easily approximate that behavior by setting this resistive or driving force curve as function of the position. Two curves, one in extension, one in retraction, and so on. And the third way is using variable assignment. Okay, so the third way, there is a mechanism manager, but we'll not have time to cover it today. So you can also define any load relationship, and you create it, and you do a variable assignment here in the cylinder. Okay, so first thing, put loads in your cylinder. The second aspect that will really increase the chance of having a good simulation using those components is to also set some of the performance curve of the components. So if I open this really valve here, you'll see that the components in Automation Studio are set to be accurate between 120, 200, 300 liter per minute. If you have a pump that is only delivering 10 liter per minute, this really valve is way too big. So those performance curve will adjust the pressure drop calculation in that case, but this will be will represent adjusting the size of the component for the flow requirements or the flow that you have in your system. Okay, so this is really important to consider. Load, performance curve of the component, and the third one, which will also be a good introduction for the point 5 of that presentation. Make sure that you are using from this main library the right components for the right function. Especially if you go in the pressure valve, you'll see there's a lot of valves here which the symbol looks approximately the same, but they have all been created, developed to for a specific function that they have to do and so on. Of course, they are structured with some functions, but we do have some valve here that will do a specific behavior. And it's easy sometimes to take the wrong component and try to make the symbol out of it. So make sure that when you double click on the component, that you know what the component is doing. So how you can get information on what this component is doing is you can always press F1 key of your keyboard, or if you click on the question mark that you have, this will prompt some help where you are exactly in the interface. So I was in data, press on F1 or the question marks. I have more information on the behavior of that pump. So you will have information about the specific models that we have, and you will also find some limitation in some of the model that we have. Okay, this is really important for you to better evaluate if this component will do the job for the simulation that you want to do, and so on. Okay, so you select the help of the component with this question marks here. If you want more information on each properties that this component have, or and so on, you just need to go and wait half a second on the properties. Tooltips will open, and this is how you're gonna get easily information on each of the properties that you have here. There's also some information that in parentheses here. So this is usually matching what you have from this picture, okay, telling you in the illustrated way what each properties means in terms of the variable or the properties that you can adjust sometime in simulation, or that you can set as you parameterize this component. Okay, so those were the 3 tips when you use this library that you need to take care of. Of course, if you use the manufacturer catalog, once again, if I get back to the third point of that presentation, by the sizing will be done. The right model will be also pre-selected for the right function. So a lot of benefits using the catalog. When you have specific function and specific performances that you are expecting to get out of your simulation. Okay, so as I explained, adjust the component from the main library. I already initiated this 0.5 for each component. If I just explore a little bit where you could get help for other aspects of the software, not only for the components, we do extract. We have created the support tab since a couple of versions now. We have extracted everything related to help on each workshop of Automation Studio, on each interface. So all the help or the guides are can be explored from there. This is where also you can, really important, you can, if there's something that you don't know how to do, you have questions, there's something weird in the, maybe report a bug or something that you find in the software, this is where you have access to your client zone, or you can directly from Automation to open the ticket. So really important that you share anything that you feel that is not according to your expectation out of Automation Studio. Really important for our development team to adjust and to make those development available. Okay. If you just want to explore, we have some questions. We also we keep updating and adding more and more information in the discussion forum. There's also file that you can access from there, that you can download, that you can run. A good example of a thermal simulation that we have put there, and so on. And there is also the frequently asked questions. So more and more we're gonna feed these pages with more information. Okay, so nothing more for that aspect. Now I'm already at the 0.6 of the presentation. Okay, structure your circuit using functional group. So for this, let me open a project that I have, okay, that contains already some of the functional group. Okay, this is that's a new concept. It's a concept that we have implemented in the latest version of Automation Studio. If you go in the tab, you go here, you have access to this functional group manager. So the functional group manager has been developed according to ISO standards to really divide an hydraulic circuit or an hydraulic system, I would say, in installation and circuit. So this, if you are using this feature efficiently, will allows you to divide or to structure your system in such a way that you decide what you want to be visible and also what you want to be simulated. Okay. Well, so this interface, use the same automation studio button, so you can add a circuit installation and so on. And what is really different compared to the layers that people used to use in the past is you can regroup, okay, a certain circuit and installation or combination of circuit and installation into a higher level. Okay, if I give you an example, just so that it's clear for everybody to understand, I have already some system or a group of installation and circuit created. So let me click on swivel function only. You'll see I have saved what are the installation and circuit that will be involved in my swivel motion. Okay, so I have the main engine, of course, on the clutch here, and I have the pump dealing with the swivel that will operate the swivel and so on. Okay, so this will allows you, as later you want to simulate, as you start the simulation, will allows you just go. Okay, we'll close those objects for now. Will allows you really to operate only function here. Okay, so what we do suggest to put in the circuit and installation is really the object that you want to be print out of your schematic, that are part really of the simulation or the technologies that you have. In that case, all the hydraulic components. We have the same concept for electrical component as well. You see, I'm not able here to operate my valve. This will allows me to open the layers manager. So the layers manager is still available from Automation Studio. It's doing a similar things than the circuit and installation, but we do suggest to use this layer manager only for the CAD object or for the object that are, I would say, Automation Studio specific. What I mean by Automation Studio specific, in Automation Studio to operate this, you will need some control element like this joystick. So if you don't want the joystick to be part of the printout and so on, it can be put on an external layout. Okay, so the layers will allow you to add the dynamic measuring instrument that we could explore a bit more in details. Labels, all the CAD object can be put here and so on. Okay, so this is the difference between the circuit and installation and the layer manager. So if I can get back here, with only one click, after you have saved a specific configuration, you have access to it. So in only one click, you select which part of the circuit you want to display or not. And from here, let me just return back to the layer and remove the dynamic measuring instrument. Okay. So that was about the functional group. Okay, now you see everything is ready to perform a simulation. I have I've set up my project with the right templates, manipulation, so my schematic is good. I have used the right components and I'm able to adjust them, make sure that I'm using the right function. And I have divided into a group of functions my circuit. Before pressing, I know that this is the first reflex that every user is having, pressing on this play sign. Before doing that, I will show you. It's always better to have in mind that there is an Automation Studio simulation options. So those simulation options can be accessed from this button here. Sorry. Okay. So there's a couple of options here that you will select depending of what is the type of simulation, what is the analysis that you want to do, what are the objectives that you want to reach by the simulation. Okay. If you are only interested to take this circuit and having an overview, an animated view of that circuit, we do suggest to keep the simulation pace, okay, the same pace that by default. So simulation pace that I'm using for my fluid system is 10 milliseconds. I would say the legacy pace of Automation Studio, we have, this is the pace used since the beginning of Automation Studio. So when you run the simulation, you are able really to perform, to operate the circuit, and the relative simulation time will match perfectly the real time. Okay, good for training, for exploration of the circuit. Don't need really to parameterize any component to do that. At the other side of the spectrum, sorry, if I return in my options, let's say that in Automation Studio, since there is a various level of simulation, you really want to go a bit deeper in the dynamic simulation, and so to get more information or transient, I would say, information of your system, you will require to activate a smaller simulation pace. We do not suggest to go smaller than 0.1. Our models are not tweaked yet, so the 0.1 will give you for the hydraulic system a really good accuracy. So with 0.1, you will have a maximum accuracy, the maximum accuracy for your hydraulic system. And if you are happy with the result that you obtain, but the simulation it's just killing the CPU because you work on a big schematic and so on, right? You're happy with the result, you could try intermediate pace to find the best compromise between good results and making sure that the simulation match the real time. Okay. So this is about simulation base. There is a lot of other functions here that you could explore that will affect the performances of your simulation, the accuracy, and so on. So as you start the project, your analysis and simulation, you can make all the lines turn perfect if you wish. This is one type of simulation that can be done. We have more and more users doing thermal evolution analysis. So the temperature is always taken into account in Automation Studio, but if you really want to measure and monitor the evolution of the temperature, so the heat generation and the heat dissipation for the components, you can check this function here. Of course, you will need to make sure that the oil will recirculate, that the components are well sized to do that type of analysis, and so on. And there's other functions like that we suggest you to explore. There is some a bit more related for about the animation, or there is one interesting, the show faulty component. So what this will do, if I go here in my cylinder, okay, and you start by you use a manufacturer component, or you change some of the limits, the operating limits of the component. So if I put 120 bar as the maximum pressure here, when I will run my simulation, I operate this, my cylinder reach the end, and you see as soon as the pressure is over 120 bar, you have this this sign appearing, meaning that you may have a problem running this cylinder at that pressure. Okay, so those are a feature that you could explore, making sure that you are selecting the one that you need depending on the simulation that you want to do. Okay, so this will end or conclude this this point 7. The point 8. Okay, we're not talking about modeling the component. We'll show you some tools that will help you really to monitor your simulation. Okay, so most of those tools, you will be able to find them in the simulation tab. So there is, of course, these measuring instruments. When you start the simulation, those can be inserted live in simulation. So you can insert, you click, you drag, you insert some on the components. So this gives you access to the physical properties, so speed, force, position, so physical parameters. So okay, so I have the linear speed of my cylinders. When I run it, you see this value will be measured from here. There are some that you can insert at the connection point. Okay, so measure pressure, temperature, viscosity of the oil here. Okay, and there is others that will measure the differential properties. Could be energy, could be by differential pressure here. For the energy will be the other one here. So this gives you really access live to really the parameters or the outputs of your simulation. You prefer a time-based evolution, or you prefer to monitor really the simulation, we have also plotters, or we suggest to add plotters really to take advantage of those, to see the circuit differently. So when you analyze the simulation, the animation gets some limits. Sometimes you need more information. So you take the component, you drag and drop them, and you make sure that you output the value, output flow, output pressure of my pump, and so on. So when you run the simulation, all the information on the desired properties that you want to plot will be available from here. So with this plotter, you can, after that, you can export the value if you wish, and so on. So the utilization of that plotter, that plotter is really important, really to monitor once again the simulation or the outputs that you have out of your circuit. Just make sure. Yes, there's another little things to analyze the system is you can implement failure in your system, really to do some troubleshooting or to see what happens if there is some default that occurs in your simulation. So what I will do here, I'm gonna lock this plotter. So this will make sure that I have the overview of my circuit when the circuit is LT. And if I go inside this component, we'll be able to go, if I go in my troubleshooting, you can declare a failure. Okay, there's some specific failure. You can also just add an external leak, for example, for each ports that you have. So this failure, I will activate it. You can declare it. You can set the properties. With the 7.1 version, also you could have different level for the failure. So you are able to test and analyze this your circuit with different leakage in that case. This will be really convenient to see, since there is always leakage in hydraulic, you'll be able to see what is the maximum acceptable leakage to make sure that the circuit meet the desired performances. Okay, in my case, I will just put that failure in, and as I run back the simulation, once again, if you want this failure to be effective, we'll need to have some load, make the pressure raise. Okay, and if I create a new plotter, you will be able to really to compare side by side an LT system. So if I just take the linear position and speed of my cylinder, you'll see you go here, you move one direction, the other direction, okay? And you see, if I zoom everything here and here, you'll see that the ramp of the displacement of my cylinder is not the same, okay, because of that leakage. So plotter, you can export the data, you can analyze them in the Excel spreadsheet type of software if need be. A really, really important feature to take advantage of really the simulation of automations. Okay, time is flying, but I think we're good with the plan system. The 0.9, just we'll just focus on one thing really important. There is a lot of documentation feature in Automation Studio, but there is one that we developed and we feel it's a little bit underused. So if I return to the already built project, okay, we have released since a couple of versions now an improved bill of material. Well, we still call it bill of material, but it's much more than that. It's really a feature that if you go in the Home tab, that will allows you to display existing information or to extract or to take advantage of the existing information for each component that you have in the circuit coming from the manufacturer and to show it efficiently. Okay, there is, once again, really important, if you click on this little arrow here, so the bill of material, the default one might not be adjusted for what you want to do. Well, in this project, since I have already defined a template of a bill of material, I have already the information the way that I want. Okay? So I have my reference here, the name of the component, some ID. So you decide which information you wish to show in your bill of material, okay, in this bill of material. Those bill of material, for example, this one can always be customized. You can add more information to it. So let's double click on it. There's a lot of information here that is available for you to structure the bill of material. Important one will be the field. So you can add existing fields from Automation Studio. You could create your own variable that will be also, you will be able also to use in this bill of material. Just to show you, the quantity is a property that is available. It wasn't displayed here. So if I just click on the quantity, you will see now I have this information that my two lifting cylinder here. Let me just show the reference that I have here. Okay, so I have my reference 7. I have all the components are listed, the one that are referenced here. Okay, just to show you, if I reference my accumulator here, will appear here. Okay, we may need to change the reference to a non-existing number. So this can be done easily. Okay. So I have here the same cylinder. Will also give me opportunity to introduce another really important aspect of Automation Studio. So you have 2 cylinders, but those 2 cylinders is part, I don't know, of a unique assembly and so on. So if I select by framing all the components here, okay, sorry, if I select my cylinder with the lines, okay, I can select them, right click, you can assemble those cylinders. Okay, so let me erase those reference. Okay, so once again, only the components that are referenced will appear in this bill of material. So if I select my assembly now containing 2 cylinders, see, I will be able to go here and to change this. So the reference of my accumulator will be the reference 8 here, and the reference here will be the reference 7 that I was having. Okay, so you change the reference. Everything is dynamic. You change something in the components and the bill of material is updated. Better than that, this is a new feature that we have in this bill of material. It's not a new feature. It's a feature that inherit from this bill of material that we have. You can also directly from here change the information. So instead of okay, we'll just make sure that I'm writing here. Okay, so I will directly write information here. Okay, so when you exit, the information is carried from the bill of material inside the assembly. So you see, so it's a bidirectional process. So with that bill of material, there's really no limits of the type of information that you can list. I can show you a couple of examples. So the standards templates are here. You have your user-defined standards here. I have created one which is called line by function. Okay? So an example of a list of all the lines per function and the quantity for each of them. Okay? And there is a variety of different lists that you can create. Just a matter of defining the fields, the information that you want in the bill of material, and saving them or saving these information in a bill of material template. Okay, so the documentation of Automation Studio, most of the information is already inside the component, and the bill of material will allows you really to display efficiently the information that you want. Okay, so this conclude the point 9 of that presentation. The point 10, it's just a short recap that I have to do. Once you have your Automation Studio project created, we do have in Automation Studio a variety of way to publish it. It was part of the webinar we gave 2 weeks ago. So short recap, make sure that you are aware of those. There's an Automation Studio viewer available that will allow you to view any Automation Studio file without having necessarily it's a free viewer. There is all these exportable format. You can create video. Okay? So make sure that you are efficient the way that you share into the right format your project to your colleagues, to your customer, to your suppliers. Okay? And make sure also that you share with us your utilization of Automation Studio. Okay, so the sharing aspect, sharing of your project, but sharing your experience with Automation Studio also with us. This concludes the point 10 of that presentation. So I hope you enjoyed. It was a webinar dedicated to regroup following the project lifecycle steps, regrouping the 10 best practices that will make sure you build really a high quality project in an efficient way. So thank you. I think Bruno, we have time for a couple of questions.
Hi, Vincent. Yes, we do. Let me just share my screen. Yeah, so if anybody hasn't posted any of their questions in the questions box, please do so now. We'll begin to review some of your questions and answer them.